Okay, this is the Earthquakes and Volcanoes PowerPoint review, and this also corresponds to the standard 8.ESS2.2. And so this directly relates to it. It's about seismic waves, seismographs, and so we're going to talk a little bit about those. But this is the seismic waves are what we use or what we see when there has been some plate movement, all related to the plate tectonics, which we've talked about earlier. But the focus is the area within the lithosphere where the rock is under stress and begins to break or move. So if you think about it, we talked about the transform boundary where there is a strike slip fault where things move side to side. It's because they're rough. They're not totally smooth and they don't just slide and keep on sliding. There's something in there that's just going to keep it from moving. And eventually that's going to get under so much stress that that's going to break, and that's going to be called the focus. And this focus is deep down inside the ground. It's way down there where the actual rock is that breaks. And when it breaks, that's when the earthquake occurs. But the energy is carried through Earth's interior and all the way across Earth's surface, so that you will feel an earthquake when it occurs. A lot of times there may be a little tremor, but definitely you're going to feel those waves. There are three types of waves. Well, obviously the first one that's going to show up is going to be called the primary wave. You think about when you went to school, you started in primary school. That was the first one. And these are going to be like an accordion movement, and they can go through solids and liquids. So these travel directly through the earth, and they're going to arrive very, very quickly. We talked about how waves travel quicker through solids than they do through liquids or through gases because the particles are so close together. So these P waves directly go through the solids and liquids. The S waves, a lot of times students think that stands for seismic waves, but the S waves actually stands for the secondary waves because they're the second waves to arrive. And this creates an up and down or side to side movement, but these can only go through liquids. So if you can think about S waves only going through liquids, P waves can go through solids or liquids. And then we have the surface wave as our third wave, and this makes the ground roll like an ocean wave. This is actually the one we will really feel. This is what may move us, is this particular surface wave. The amount of earthquake damage or shaking that is felt is rated using the modified Mercalli scale. So the damage or shaking is the modified Mercalli. Now there's really no easy way for me to explain how to differentiate between the three that we're going to talk about, but you'll just have to find a way for you to do that. When I was in class, we talked about MMS, that modified Mercalli, and to think about it damaged the Madisonville Middle School, maybe shaking a little bit. And that was one way that we could think about the amount of shaking is the modified Mercalli scale. The magnitude of an earthquake is measured on a seismograph using the Richter scale or the moment magnitude scale. And the magnitude is nothing more than the earthquake's size. So if you think about magnitude of a situation, that would be the size of the situation. So that's one way you can think about it. And then the Richter scale uses the seismograph information to see how large or small the earthquake is, or the earthquakes are. As you can tell, you may have seen like a drum that's rolling and then like a pin that's just stuck on that and making a line. And if the drum started to shake, and then the line's going to start moving back and forth. And obviously, the more that it moves, the greater the size of that earthquake. And so that's called the Richter scale. And then, once again, let me move myself out of the way. The moment magnitude scale. It rates the total energy released by an earthquake. This is the number that you hear quoted a lot of times. If it's a really, really bad earthquake, they're going to give you a lot higher number than one that's really, really low. The ones that we have around here may be a 2 or a 3, but you may have some as high as 7, and you certainly wouldn't want to have one as high as an 8 or so. That would be very, very devastating. But you need at least 3 seismographs in order to locate the epicenter of an earthquake. Now, we talked about the focus of an earthquake being the spot, the very rock down inside the earth that actually breaks. That's going to be the focus of an earthquake. But directly above the focus is going to be the epicenter. That's going to be the place on earth where we could stand and say, right down below me was the focus of this earthquake. That's where the rock broke, directly below me. And then the energy is going to be carried out in all directions from around me. But it all starts at that very, very center portion, and that is the epicenter. But if we wanted to determine where that started, one example that I used in class was that if I was in Madisonville and I was talking to someone in Tellico and there was an earthquake occurring, we might be able to determine if the earthquake epicenter was closer to Tellico or Madisonville based on how much shaking or how much energy that the person in Tellico felt as opposed to Madisonville. But all we can really determine from that is whether or not it's closer to Madisonville or closer to Tellico. You need that third party, that third information source to really locate exactly where it happened. If we were on a three-way call with a student from Madisonville, Tellico, and then maybe Von Orr, then you could start to really pinpoint where this earthquake originated. So if by the same way, you would need at least 3 seismographs in order to locate the epicenter of that earthquake. Obviously, if the student in Von Orr and Tellico felt it extremely, an extreme amount of shaking, and I just felt a little bit in Madisonville, then I'm going to know that the epicenter is going to be closer toward the Von Orr Tellico side up in that area. And you could do what's called triangulation in order to determine where the center of the earthquake was. Then talking about volcanoes and plate tectonics, magma is the molten material below Earth's crust. Now, what's the difference in magma and lava? As far as what you would touch or see or smell or anything like that, they're going to be exactly the same thing. The only difference is that magma is underground and the lava is what we see coming out or on top of the ground. So when magma reaches Earth's surface, it's called lava. Volcanoes form along the boundaries of Earth's plates, and these can happen at both divergent and convergent boundaries. Those boundaries where the Earth is pulling apart, you could have magma coming through and creating a volcano. You could also have them at a convergent boundary where they're pushing together and then magma can erupt. And that's where we get the Ring of Fire. And this is a belt of volcanoes that occurs along the rim of the Pacific Ocean. Okay, this is a light picture, but this shows you the Pacific Ocean right here in the middle. And then around it, around the edge of this plate, where it goes all the way around, there are volcanoes all around this boundary. And if you look right over in this area, this is right around the San Andreas Fault. This is around in California. This is around San Francisco, that area. And that's important to us, but this Ring of Fire actually goes all the way around this plate. And so there are so many volcanoes that it is called the Ring of Fire. Okay, and a volcano can also form above a hot spot. And although these are not occurring at a convergent or a divergent or a transform boundary, these are where the plate just goes over a hot spot in the magma and it burns through, you might say. And so when the magma erupts through the crust and reaches the surface, this is the way the Hawaiian Islands were formed. There's a hot spot in the magma right there, and the crust might have been a little bit thinner. But either way, as it went over that hot spot, I like to think of it as being burned through. The magma comes through, and over time, it's going to come up even all the way out of the ocean and create an island. And then, as those islands trickled, as the plate kept moving, then a new island was created, a new volcano. And then that one slid on, and a new island, and another. And so there were a few islands that were created and therefore we call those the Hawaiian Islands, but those formed above a hot spot where magma erupted through the crust. The hot spots stay in one place for many millions of years while plates move over them. When a volcano erupts, the force of the expanding gases pushes magma from the magma chamber through the pipe until it flows or explodes out of the vent. And there are two types of eruptions. They are quiet eruptions and there are explosive eruptions. The quiet ones have a hot, thin, runny magma with low silica content. I'm trying to stay out of the way with my picture, sorry. And then you have the explosive ones that are thick and sticky magma with a high silica content. The way that I would think that you would try to remember this is that if it's thick and sticky, it may have kind of plugged up the hole to where it was building up a lot of pressure behind it because it was so thick. And then as the pressure built up, it'll eventually pop or explode, and that thick, sticky magma with a high silica content is going to explode out. So there's your explosive eruption. You think, well, it has a high silica content, and that silica probably helps it to stick together and to become thicker and stickier. On the other side, a quiet eruption is going to be one that's just going to ooze out. It's going to be hot and thin, and it's going to run out of the volcano. A lot of times you may see pictures of that lava just rolling down a mountain, just kind of running out of it. And this doesn't have a lot of silica in it, so it's not going to be stuck together and be real thick. It's going to be a hot, thin, running magma, and this is a quiet eruption, not an explosive one. And then one of the most dangerous parts of a volcanic eruption is the pyroclastic flow. And this has hot gases and ash cinders and hot rocks and other materials that come blowing out of a volcano. And these can be very deadly, obviously, because you're going to have a hard time breathing this. And it's going to be so hot, it's just going to destroy everything in its path. I had spoken earlier on one of the other videos about Mount St. Helens, and there were actually camera crews set up on an adjacent mountain, trying to film or watch Mount St. Helens if and when it erupted. And when it did, they were actually too close, and the pyroclastic flow actually reached them, even though they were a long distance away on an adjacent mountain. But they were killed, and there's lots of stories on the internet about that. And you may even find a special sometime on that. But it's very, very dangerous. So keep in mind those types of eruptions. There are three stages in the life cycle of a volcano. Well, they're going to be active. This is a live volcano that's erupting and showing signs of an eruption in the near future. You obviously would not want to be hanging out around one that you think or that scientists are predicting is going to explode at any or erupt at any particular time. And then there are dormant, sleeping volcanoes that scientists expect that may erupt in the future. And then there are dead volcanoes that are probably never going to erupt again. If you think about some of those on the Hawaiian Islands that we had talked about, where they had already gone over the hot spot, the chances of those erupting are not going to be as high as one that is directly above the hot spot. Not saying it can't, but it may not. But these are considered dead. They're extinct. It's probably never going to erupt again. So the three stages in the life cycle of a volcano are they are active, they are sleeping, or they're dead. So active, dormant, extinct. And those are going to be the three stages in the life cycle of a volcano. And here's just a picture, and this is obviously you can see this lava coming down. How do I know it's lava? Well, I can see it. It's on top of the ground. If it were underground, it would be called, that's right, magma. Anyway, I hope you've enjoyed this second part of the earthquake and volcano PowerPoint. This correlates directly with the standard 8.ESS 2.2. And so you can use this for a review of the seismographs and the seismic waves standard in your, uh, that you had to learn about this year. Anyway, I hope you all are staying safe. Miss you as usual, and I will see you on my next video.